Okay, in this video lesson, we are going to be adding and subtracting rational expressions. Now, remember when we consider our parent function of our rational function, we have 1 over x. So we have a fraction. And of course, anytime we add and subtract fractions, we have to consider the denominator. We have to have a common denominator. So this lesson is primarily about that, about identifying a common denominator so that we can add or subtract our fractions. All right, so let's take a look at example 1. So here we have 7x divided by or over x plus 2 plus x plus 5 over x plus 3. All right, so both of these fractions have a different denominator. So a lot of times to find a common denominator, you can just simply multiply them together. Now, we could actually just represent this common denominator as x plus 2 times x plus 3. But what we'll need to notice in this first one is that we're going to have to multiply this fraction on the left times x plus 3, because that's not what's part of this fraction. So again, if I have 7 over x plus 2 and I need a common denominator, I'm going to be multiplying by this x plus 3 over everything over here. So x plus 3 over x plus 3. So now the denominator shows that we're multiplying these two together, and that's our common denominator. But we're going to need to go ahead and distribute this 7x. Actually, that's supposed to be a 7x. All right. Plus, and then on the fraction on the right here, we have x plus 5 over x plus 3. And what's missing for the denominator on this side is the x plus 2. So we're going to need to multiply the left side times the x plus 2. So we multiply the numerator and the numerator times the x plus 2. Now it's just a matter of distributing the 7x here and the x plus 5 here. So I'm going to pause and work that out real quick. Okay, so now you can see that on this left side here with the fraction, we have 7x squared plus 21x, all divided by the x plus 2 times x plus 3. Over here on the right side, in the numerator, we have x plus 5 that we have to multiply times x plus 2. So you're going to have to FOIL these two because it's a binomial times another binomial. All right, and when we do that, we get x squared plus 7x plus 10, and of course, all over the common denominator of x plus 3 times x plus 2. Now, these two numerators are being added together. I went ahead and put this second one in parentheses. It doesn't matter as much on this one because they're all positives, but if this had been a subtraction, you want to be sure to put all of this in parentheses. But now we just can combine our like terms in the numerator, and then we have our common denominator, and we can go from there. So let me do that real quick. So in the numerator, we now have 8x squared plus 28x plus 10, and then divided by x plus 2 over x plus 3. Now, if we could factor the numerator and end up with a common factor of anything in the denominator, such as x plus 2, x plus 3, that would cancel each other out, we would do so. But it looks like at this point, we really can't factor that into common factors, so this would be our solution. All right, let's move to another example. Okay, in this example, we have 7 over 9x squared plus x over 3x squared plus 3x. Okay, so we could simply multiply 7 times the denominator on the right, and then add that to the x, the numerator of the fraction on the right, times the denominator on the left, because we could just multiply our denominators to have the common denominator. But I want to show you how to find the least common denominator. So the 9x squared you could think of as 3x times 3x, okay? And then on the right side, if we factor out the common factor of 3x, we would be left with 3x times x plus 1. Okay, so what we have then, as far as our least common denominator, is the 3x times x plus 1 and a 3x on the left, because these two, like on the left side, we already have 9x, and 3x is a factor of that 9x. So we don't need to represent necessarily both of them. So what we're going to need to multiply by each numerator, the common denominator, is the 3x times 3x times x plus 1. But when we work the fraction on the left side, 7 over 9x squared, okay, it already has the 3x and the 3x, so it's just missing x plus 1. So we're going to need to multiply the numerator times x plus 1. I'm sorry, the numerator and the denominator times x plus 1. And actually, this 9x squared times x plus 1 becomes our common denominator. All right, but then on the right side, or the fraction on the right, we're going to add that to x over 3x squared plus 3x. And the common denominator that we need to multiply by for the least common denominator is one of the 3x's that makes up the 9x squared, because we already have one of them in our denominator. So we're going to multiply both sides times 3x over 3x, okay? So let me go ahead and do the multiplication now, where I multiply the numerators and we have our common denominator. So we're going to have 7x plus 7 plus 3x squared. That's 7 times x and 7 times 1, and then x times 3x is 3x squared. Now our common denominator is the 9x squared times x plus 1. And if that's a little confusing, I went ahead and did the multiplication of this one here. 3x squared plus 3x times 3x was 9x cubed plus 9x squared. Then I factored out the 9x squared, and I was left with x plus 1. So again, that is our common denominator. And when you look up here, again, if we could simplify this numerator and find a common factor with the denominator, we could factor that out and simplify our answer a little bit more. But at this point, we have found our final solution, our sum. Okay? All right, one more example. So here with example 3, we have x plus 2 divided by 2x minus 2 minus negative 2x minus 1 over x squared minus 4x plus 3. So this is a subtraction problem, but we still need to find a common denominator. Now I'm going to go ahead and simplify these two to find my least common denominator. So I have 2 times x minus 1. And then on the right, let's see, that's a trinomial. We factor that out as x minus 3, x minus 1. Okay, so our common denominator then is going to be the 2, the x minus 1, and the x minus 3, because we already have this x minus 1 over here. So 2 times x minus 1 times x minus 3 is our common denominator. That means with the fraction over here on the left, the x plus 2 over 2x minus 2, we need to multiply that times the x minus 3, the factor of the denominator on the right side that's not part of this denominator, x minus 3. And then, of course, this is a subtraction problem. I'm going to go ahead and put the rest of this in parentheses. So the numerator is negative 2x minus 1 of this fraction that we're subtracting. And then I'll just leave it as x minus 3 times x minus 1, the simplified form here, okay? Well, you can see we have the factors x minus 3 and x minus 1, but what we do not have is the 2. So I need to multiply this by a 2. So I'm going to multiply the numerator and the denominator by 2. By the way, I could have simply written this down here as 2 times x minus 1. Let me do that real quick. I can just take that out, and we'll call this a 1, 2x minus 1, just so that you see it in factored form. Okay, so it says the same thing. All right, now what I need to do is go ahead and do this multiplication, because again, here we have x plus 2 times x minus 3, and this is a binomial. We're going to have to FOIL this, okay? And then over here on the right, we're just going to distribute 2 to the negative 2x minus 1. Okay, so now what we have when we FOIL this, we get x squared minus x minus 6. And then I have minus, and then I left in parentheses, when we 2 times negative 2x is negative 4x, and 2 times negative 1 is minus 2, okay? And I have my common denominator of 2 times x minus 1 times x minus 3. Now in my numerator, I just need to combine all of my like terms. Be careful here, you're actually subtracting a negative 4x, which makes that plus 4x. And then minus the negative 2 would make that plus 2. Let me go ahead and combine those terms now. So you can see here in the numerator we have x squared plus 3x minus 4. We're going to combine all those like terms, all over 2 times x minus 1 times x minus 3. Now normally we would be finished. However, this trinomial, x squared plus 3x minus 4, can be factored. We find the factors of -4 that equal 3. That's going to be 4 minus 1. So if we rewrote the numerator as x plus 4 times x minus 1, and then all of that is over 2 times x minus 1 times x minus 3, you can see that we have a common denominator of the x minus 1 that will factor out. Now remember, in terms of our domain, we would need to know that this is true for the values of x that are not equal to 1, because that would give us a 0. So what we have left is our x plus 4 over 2 times x minus 3. So we'll write that as our final answer. 2 times x plus 4 all over x minus 3. That will be our final sum. All right, and that's a quick video on adding and subtracting rational expressions.